Welcome, Michael at Wickerson Studios. I'm basically going through the algorithms for Dummies and translating it into Grasshopper for Rhino3D, and I'm doing more than I was doing a year ago on this project, and I hope people will find it valuable. I'm going to focus on Chapter 4, this script, which is the 8th iteration of it. As I completed it, I've basically gone through all the calculations for using vectors and matrices in Chapter 4. So initially, you're going to have to learn how to get a GhPython remote component up and running on your computer. That'll be in the Maths tab, and you'll be able to actually see it here, and you'll have a little remote button on it, and you'll be able to pull it in. Basically, the book itself, the goal of mathematical algorithms is to turn one kind of data into another kind of data. Time to learn how to create your own library of hand-coded algorithms. Discover how to speed up calculations so you spend less time manipulating the data and more time doing something really interesting with it. Performing calculations using vector matrices, you can think of scalar as a number, vector as a list, and matrix as pretty much what Grasshopper thinks of as a tree, a list of lists. Anything you need to know about Numpy package, you can look at numpy.org. That's what you want to start using, and the GhPython Remote will allow you to start importing that. You will have to set up, and it gets a little complex. You'll have to work through your Anaconda, and you'll have to make sure you have an interpreter up and running. I have several up and running for some reason. But basically, example, my short, you'll import numpy as np, you'll start a variable np as a short 15, and then comment a will then have a 16-bit long script. So a very simple one. But what you want to do is, let's have a look at numpy array to start in the Grasshopper canvas and the GhPython remote component. You have to get this up and running. You have to locate where you have Rhino remote on your computer. You will have to import libraries, and it will tell you the import stations you'll have to use in your Python node, because you still have to put everything into Python nodes, which means you need to know how to set types and set access as well. So this is not really for beginners. RPY is interesting in here, showing you what is running in Iron Python, and your link modules are also NumPy. It's just coming out of here. It's not really that important. It's more the important statements here, and then the out factor is telling you everything that's running as it's going through. I'd like to leave it on the import statements and plug in whatever I needed as needed, because that will run everything on this canvas, which is the entire chapter 4. Now, I'm not going to sit here and script everything, but I'm going to show you the details of what I've done. One thing I've done, according to how they've written Python Remote, is you can't just print and have it all go to output. It's not going to do you any good. You can't do anything with an array that doesn't even have commas and all these classes of what's going on. You're going to have to find a way to pull it in. So let's take a look at this one, ABCD. Let's open it up, take a look exactly what I put in here, and I'll try and show each one in detail. And it starts with chapter 4, and I literally am translating it like a medieval monk, just writing it out. I've got an import statement. I do have to import script context as a C, and I have to import RhinoPython Remote. If I don't do that, it will not use my RhinoPython Remote. It does not. Now, the trick with this is Grasshopper does not recognize remote list objects as lists. So from GhPython library tree helpers, you must import list to tree. And once you do that, you'll be able to take anything you write. I also have to import NumPy equaling sc.sticky as NumPy, and RPY as scsticky as RPY. And these are examples in the guidelines how to use Rhino Remote. Once I start adding import items, I just kind of leave them whether they're in use or not. It's not like C# where it'll kind of fade out if it's not in use. Best to just put them all in there and see what happens. I'm producing a vector. That's a NumPy array, and I'm setting it to ABCD, and I stopped doing this as I went farther in. I was just hard coding arrays, but here's your array. You're going to print your array, and there it's printed in the output, because you have to use your output to debug this stuff. And everything in these books, even though I'm looking at a 2022 book, there's still errors, there's still things that don't translate into Grasshopper, but that's the service I'm providing. If you're interested, I'll share these files on my Patreon and on GitHub, and hopefully people will reach out to me and have questions about this. I also like to type, so I know what type is actually happening. And whenever I have an array, then I know what I have to do here. And I'm going to have my vector out. I just typed in here. I could just leave it my vector, my vect, and then they need to be recovered onto the local interpreter first. So I have to take that out function. I have to use the GhPython Remote obtain my and you got to type this in every time, no matter what you call it. If you called it my vect, you have to change this all to my vec. That will make it into a list. You can type a myvec out as and see what it is. It'll come up as a type list at that point, and this is a good example of why you would have print print type my vector out, because everything is myvec out. And that's going to print here after this line, and you'll see what happens as I run it. Test, and there you go, you have a list. And then if I wanted to print my print out here, after I've then converted the list to a tree, myvec out, source 00 is not that necessary. You can actually run it without it, and I'll show that. But let's take this again. You see now you have a data tree object. Very nice to have. And if I took out this comment, I think I can remove that totally and everything still works fine. But I'm going to leave it in because that's the sample that comes in the guidebook for RHINO3D Remote. So that's a great example to get you up and running. What I then do is I go on and I say, well, let's take a look at something a little different. We're going to have a range of a start and end and a step between it. And I'm going to write that script. And here it is. Same thing. You're going to jump in, write that script. It's best to just get a copy of this off of my GitHub. That'll be a lot faster than you doing this. I leave all my import statements as I do. If I have to add ones, I will. But you can see my vector is now a numpy a range, start and step. Not range, but a range. Print myvec, print myvec. I actually asked to print just the 0 element in that. I have to wonder if I take this out, what's going to happen. It's going to run fine as well. But I'm going to actually leave that in there for a second because I just want that to be the element that I'm using in my vec type. It's not really necessary. It's just something I was playing around with. And then you can see that I'm changing my numpy integer 16. I'm changing that from what it was, an integer 32, to an integer 16. And that's just a nice little way to start changing types. The same memory space or whatever you want. And then myvec out, you have to use the same thing. GhPython Remote, obtain, you must take it to list, and you must take it to tree. And once again, you can type your types. As soon as you see an array in here, you can actually move it through that. It will get complicated when we use booleans and tuples. So let's just continue with the party as we keep going. Let's take a look at the next one. This is one that's going to do a multi-dimensional array. It's going to build a matrix. And that matrix can be provided by pulling in the libraries the same way. My vector is now a numpy, a range of rows times columns. And then I want to reshape it as a function by rows and columns. And I've hard-coded that in. So I can make a really nice control of trees and organize trees. And you see what's happening on my matrix out. And what a tool to start laying hold of data structures and understanding data trees better, because you're building them through your coding methods. And you're not going to get lost in this. You can keep scripts very tight and beautiful. So I'm really enjoying how this applies directly over to Grasshopper and Rhino. Let's perform basic functions on vectors and matrices. And what I have here is a simple, very simple vector that's created the exact same way as I produced my last one, but I wanted to have an addition factor so I can add to every element in that list. As you see, it ranges through here. 0, 1, 2, 3, 4 is the original matrix. I can range through that, but if I want to change my rows and columns, I can change that from 3 by 5, 3 by 4, and I still have control to change all that data. What a wonderful way to do this through Python as opposed to using nodes and pull yourself a little bit out of vanilla Grasshopper tools and into something like this. Really powerful applying this this book, and I'm going to go right through the whole thing this summer. I'm so excited about it, and I hope you're excited too. Let's go into the next one, which is now dealing with booleans, and this took me a little bit of fuddy-duddy, chuddy-muddy, squibby. You know, it was a little nuts because what's happening, if I produce two arrays and I'm checking if they're equal, it does not produce integer arrays or number arrays. It produces a Boolean list. And it's false, true, because is 1 equal to 2? No. 2 equals 2? Yes. 3 equals to 4? False. 4 equals to 4 is true. But you have to check that type. And you'll see I have an array here, which is nice, on C, which is that calculation. I want to push the last two, A and B, through using the same techniques to see the lists into trees if necessary. But the last one, you'll see I can do the exact same thing because it is an array and I've checked the type and I'm able to just push it simply into here. It took a little bit of fudging around. I don't know why. I was just thrown because I wasn't using integer types, but I still managed to pull the list out of it. You can tell by the square parentheses, and now you have data that you can use. So with the out key, you're not getting any of that data. You've got to find a way to process it through so you can use it, and you must use this obtain to list, and you must obviously change A in every part, B in every part, C in every part. But you really practice this book, and you get better and better at using your out on your nodes. So let's keep going. What I've done here is pretty much the basic intro that got me started. It's not too exciting. It's pretty simple. It was basically saying, let's take a range at GhPython, deliver an RPY, sticky RPY to the range 100, and then it will list the whole thing. Now, I did not put the output. I did not push this through, which is what I should do if I want to see it as an output that's accessible. So let's just use that as an example, because this is what I was doing before I learned how to manipulate all this. Let's go into here, and let's just cut and paste that data, because we want, we don't want to make a typo in it. So just, I try not to cut and paste too much, but let's go back into here and let's take that range and let's put it out there, and let's change that range cup to paste. Make sure you get all 4 sections or you're not going to have it. Paste and paste, and let's put this out. And I've got a problem with it. Attribute to list has no attribute list. Let me see what's happened. Back up to this one. What have I done? Range. That is doing something complex. I may have to take a look at it. Actually, I'm not going to, because I forgot I solved it. So let me get rid of all this, go back to what I had, type it, and then what would I have done to solve this problem, to pull it out? And I did it and got it into this list. Let's see what actually was the answer to that. So what I had to do was jump in here, and I did do that. However, I gave the range I had to name it before I just used it. So I had to take the function, the numpy range, and then I had to treat it as a variable, and I pulled it out, and that's exactly what I did. So I was trying to do 2 steps in one, and it can get a little funky, and I shouldn't have done that. But I did solve the solution down here. So if you've got it working in the out, and you want to find a way to process it through, you're going to have to use the obtain to list and then list to tree, and you should be okay, so long as your type, if I take a look at print type A, you're going to see as I do that, what did I do wrong? I probably need another comma, and there it is. There's your type A, and it will be an array. And as soon as it's an numpy array, then you'll be able to pull it through. So nice example as well. I almost got tricked up on my own scripts, but let's get back into the whole thing. You see, I'm actually going to go through this. It's going to be a longer video, but it's worth taking a look at. Performing vector multiplication, you need to use the dot project, because even though we could get in here and we could do what we were doing over here, which was just providing addition and doing it kind of sloppy, what happens when we get into a matrix is performing vector multiplication is possible. You'll need to use the dot project, which is the sum of the projects of 2 sequences. The dot project is always the sum of the individual element by element multiplications and results in a single number. Creating a matrix is the right way to start. Simply use array function that you would use with the vector, but you must define the dimensions. So that's exactly what we have to do. The rows in one direction, the columns in the second direction. And as we get into multiplication, you'll see how this gets complicated. So let's take a look here. And you are now up in NumPy. You pull in your libraries. I don't have to add anything new to it. I have my matrix, which is a number array, and I can list as many within that, a list of lists, a list of arrays, an array of arrays, and I can print that matrix, which comes up here. But how am I going to output it as trees? Well, the matrix is the exact same thing as a vector. You're going to use the exact same obtain, because we can check the type of this as well. Print my matrix and print type my matrix, and you really want to make a habit of this. Print my matrix type, and you'll see that I have the array, and as soon as I have the array functioning for me, I can take that array and I can start to do some magic with it and pull it out. And that's really the key trick that takes a little bit of finesse figuring out what that is. Let's go on to the next one. Here's another array right here. I pulled it out, and I think I did the same thing, but I did addition. So I can take 2 arrays. You can see that I've outputted the 1. Even though I didn't, I've only chose to print A and B, which is actually adding these 2 vectors together. And plus, adding a vector is no problem. You can see that you can just add one to the other. And I've just chosen A plus B. Will be interesting if we start to do multiplication because we're dealing with matrices, so let's continue with that. The dot product works completely different with matrices. In this case, the number of the matrix must match the number of rows in the matrix B. However, the number of rows can be any number, and the in A can be any number, and the number of columns in B can be any number. So what we have here is the ability for us to go in and generate so long as the rows, the columns in A, 1, 2, 3, match the rows 1, 2, 3 in B, the columns in B. So we have the rows matching those in A and B. So let's take a look at what happens when we do A dot B. We're going to be generating this matrix from those past two, which is pretty interesting numbers if you take a look, and then we can still pull it through the exact same way. Dot product is completely different with matrices, so I put that right in the script so you can remember that and get your columns. Otherwise, it will not work if you start to have things like if this one was, if I hashtagged out this, I'm not sure, no, but hashtag out everything. Let me just take this out. I'm just going to cut it for now, and I'm going to run it, and you'll see it'll default because it's not the right number. So we need to put that back in. We need to put that back, and then we can run it, and you'll see that that one actually works. Defining advanced matrix operations, you use the reshape function and lets you put data in any shape you need. In fact, you can reshape a vector into a matrix. Absolutely fantastic. So let's take a look at what we have here. We actually have made a 2 by 2 by 2 matrix out of a matrix that has 8, which will work because you can take 8 numbers and divide them into 2 plus 2 plus 2 plus 2. You cannot do this. You can actually reshape it into 2 by 2. At least I thought I could. How would I change? I would change it into 2 by 2 so long as y was 3. Or y was, yeah, y was 3. Now let me think why that's working for a second. 3 by 3, no, 2 by 2, 4 by 2. What was I doing? I got my head a little bit outside of what it's used to. Let me put it back into 2 by 2. I'm taking those numbers, putting them into 2 by 2. What happens if I put them in 1 by 8? That might be interesting. But then again, this is what it's defaulting to as I change the set. X, Y, Z. Oh, it's because of the if when I multiply these three together. I've got to change my script. If I'm going to go 2 by 2, I've got to eliminate Z as well, I believe. And will that work if this is 4? How does it work if it's 2 by 3? Oh, change the shape in 4 by 4. No, can't do 4 by 4. 2, 1. Let me just think about this for a second. 1 second. All right, I had Z up and running, but I need 2 by 4. So I took 2 with 4 numbers in each, and that would actually work. But that's not using the Z in the multiplier. So it does get confusing because you have to define things. I'm going to put it back to what it was because it made more sense to me as a set of, I don't want vectors, I actually want my other one's running. So let me check this out, and then just slide this one back to 2, and it should function right back into 2 by 2 matrices, and that's what they end up being as a tree data. Otherwise, I just put a little catch-all there that will produce an error. That's a little something that I put in there. Just anybody with some basic Python would ended up doing that. Sorry for that little confusion. Okay, transpose and inverse matrices. We're going to look at the transpose message to start, which is pretty nice. And I've got a matrix here that I can build that matrix. I've hard-coded it in 1, 2, 3, 4 in 1, so this is an array and arrays, and 5, 6, 7, 8, and I want to change that. If I want to transpose it, it's just going to flip it. So it's going to turn that vector, matrices out, which it was an array of 2. It's going to change it into this arrangement here. Let me hit go. There we go. And you've got a tree 2 by 2 by 2 by 2, and you should have your output a 1, 5, 2, 6, 3, 7, and 5 and 4, 8, as opposed to 1, 2, 3, 4, and 5, 6, 7, 8. So that's the use of a transpose. I did go into the inverse matrices. The identity inverse matrix next. The identity matrix is something that you want to wrap your head around. So we'll jump into this one, and it's pretty sweet. And this should all be like grade 10 algebra if you think back to it. Now, whether you applied it through algorithms and then brought it into Grasshopper, I don't know if you've done that. I am using in this one a special case lin ELG or LINALG inverse and all close just to double check it, and we're proofing once again. We're proving a Boolean. So because we're doing a test on this, it's actually going to prove if it's within a tolerance or within it's close enough. So I did produce additionally, you can produce an identity matrix any way you want. So I can type in a number here and have it 5 by 5 identity matrix. It'll put ones along the diagonal, and then you can use that to scale and do things off of that one by one. It's kind of like scaling things perfectly, at least in my opinion. NumPy array, I'm going to produce 1, 2, and 3, 4. That's an array and array. And then I'm going to translate that into using this function LINALG to the inverse, which is the inverse matrix. And it does end up using, if you want to check things, the NumPy all close using the dot project to that identity. Are they close? And then you end up having true that they are. So interesting that you end up getting these two. And in the end, Grasshopper lists to tree. It should work the same because that was I could turn it into a list, I could turn it into a data tree, I could turn it into a list, turn it into a data tree. So I did that with A and B just to make sure things were working fine. And I'm not sure why. Oh, I just put the print in there just to show what it looked like as an array A and B. Anyway, it gets a little more abstract in your mind, but as long as you got everything up and running, you can start to think to transpose and to inverse these matrices. That said, I kind of ended that a little bit. And what was the last section? It was creating combinations in the right way. So we're thinking of permutations, commutations, and that's exactly what we're going to look at. Permutations, combinations, and repetitions. Data isn't simply a sequence of numbers. It represents a meaningful sequence that, when ordered the proper way, conveys information to the viewer. Distinguishing permutations, creating a data permutation, reordering the data so that it presents a different view might help achieve a desired result. And one you can use is NumPy random permutation function. So let's jump in here, and basically I like this because I can produce a function from these numbers, 4, 7, 10, and find all permutations through it. And I just have to do a little bit of for statement in here to make it work. I did something here because I thought it was interesting to throw in a new list, which would calculate for me if I wanted it. If I wanted to print the new list, you can see what it's actually doing. It's just counting 0, 1, 2, all of the, I meant to hit test. It's counting how many are in those permutations. 4, 7, 10 would be elements 0, 1, and 2, and that's counting that for each one. Now that's not really necessary. It's just something that I'm playing around with to allow for visualizing what I wanted to do. That print new list is not necessary. I'll just hashtag it out, and you can leave it out if you want to. But now it's going to write all the permutations, and then what's tricky there is you have to go in and you want to, for P and permutations, you want to append a list, which means you have to make a list. Make an empty list, then append that list, and then you'll be able to put that list out. And you don't have to do any array to list because you're dealing in a list, and then list to tree, because that's exactly what it is. So you can just put that right out as data, and you've got what's dealing with here is the permutations produce tuples, immutable ranges of numbers that you can't just go in and change these ones. This one's 4, 7, 10. This one's 4, 10, 7, and they have to remain that. Now, how I'm going to use tuples in Grasshopper is very interesting because Grasshopper 2 has a section. Just for those, for a little highlight here, if you go into and you've got your working process, and this is kind of exciting, G2, and you want to load up Grasshopper 2. I hope it doesn't crash my program. Let's give it a second. Yeah, it probably will. Whenever you do too much in Grasshopper 2. Oh, I've got Grasshopper 7 open. I don't have my work in process Grasshopper 8 up and running. But if I did, you'll notice there's some huge sections in tuples that I'm hoping to look forward to and figure out. Shuffling combinations, sometimes you realize you need a few members of a combination of a specific length. So combinations is another tool. And the one thing I didn't mention in the last one and this one, you need to import from intertools, import combinations. And if I go back to the last one, I didn't catch this when I did it, you will need to import from intertools, import permutations. So if you're not pulling these aspects of the library, you're not going to be up and running running this. So I'm just going to leave them in here from now on. I'll probably leave permutations and combinations as added forms. And so I'm going to produce an array 1, 2, 3, 4. I'm going to make an empty list, and from combinations, I'm going to produce that list, and you'll see it will make every combination that can come out of that, and it chooses 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, then 3, 4. So it's a nice little tool. If you think about it, print your combinations, you'll append the list, and you can just print it because it's not an array, it's a list. You've got it as output, and you can start using those tuples once again when you find out how to use tuples in Grasshopper. All right, then we have a random sample, which should be familiar to everybody, and people are like, well, why do I want to know all this about Python when I can just use the random functions? Random functions are huge in Grasshopper too, but let's take a look at what the script says. I've imported everything. I've also had to import random, so I produce an array, 1, 2, 3, 4. I thought I would have to use what I had before, all of this, but all I needed was the A array, so I don't need all this other crap that I had in the last function, so I will delete it, and I'm just making a pool as a blank array, and then 4, or a blank list, so 4 combinations in combing combinations A2. I want to know basically all the combinations I can get, and that's going to add up 1, 2, 1, 3, simply 1, 4, 2, 3, 2, 4, and 3, 4, which we already did. But I'm going to randomize them into a pool of, say, 3. So if I wanted a pool, now what's nice is I could put here and say count, and I will have to do type int integers and keep it a single access. And now I'm just going to choose 3 because that was working fine. I have to put in my numbers just so it's a little more parametric. Count, and see what happens. So let's hit test, and there we go. It's running, and it took a little longer to do it. So we've got a count, and now as I can change, I can do 4 count. And then every time I run this, what's nice is it's a random. I'll produce a seed, and you could seed this if you wanted by going into random and use a seed, but we can get there later when we want to go to the details. But it's nice that you could random that data whenever you want, whenever you run that script, and whenever you open it. Okay, so very cool. And then facing reputations is always the almost last thing, but I began with, if you remember, I began with a video before I started this series and got all of my GhPython Remote up. I taught about recursion and iterations, which we will end with. But right now, facing repetition, list set at A is a wonderful tool because you can take a list that's got multiple numbers in it, you write that in, and it basically takes that array, and I push that through to a list and through to a tree, and it only shows me the single numbers that are used in that original list. I'm going to take a break because I have a little daughter talking, and we'll finish up with recursion and iteration. Okay. What I did here was explaining recursion. In recursion, you call a Python function. It does something, then you call it again. And what I've done here was I brought it and just left it because there was too many strings involved here. So I wrote it out, and I actually corrected a little bit in the script as I go into it, that you can change your factorial. And I will leave this to you to watch the first video that I covered in detail going through this. At least I think I went through it. It's the first video in this series, but I imported all the text over here. So you're going to talk a little bit about, yeah, I did a video of this explaining recursion. You can write it in different ways, and then you can eliminate what's called tail. What's that called? Tail. What do they call it? It's like tail counting or something. I have to remember it. But anyhow, I showed the little ways of writing it, and then in the end, I think we use a while loop in the last one. Yeah, while it's greater than 1. And I'll leave that for people that actually watch the first video. I'm not going to spend any time on the recursion. What's nice is you don't need Numpy at all. You don't need anything. You just write a definition for factorial and get it offline, and then you can produce it. But once again, what's the point? Because Grasshopper itself has wonderful tools like the factorial here. The only thing is you might want to get in here and find out a little more information about it, and learn a little bit more and really visualize instead of visualize what's happening as it counts down as opposed to just giving you the final number. So if you want to visualize the data in recursion and iteration, then you take a look at these 3 scripts as we go through. I have one last thing to go through. Performing a task more quickly, consider divide and conquer, and I've got a really nice script in here that basically splits the content of a question in half, compares the keys for content with the search item term, chooses half that content that contains the key, and repeats steps 1 to 3 until you find that key. So the writing of this is really else statements and else statements, and that should be common to people should be able to make sense of that. Import, you don't need anything. You're writing a definition. You don't need, once again, for these last ones, which is why I started with them, you don't need Python Remote. You don't need Numpy. You don't need scikit-learn. You don't need matplotlib library. You can just go in and write your script, write out, do your search, follow through this one. I'm not going to cover it in details because it's here for if you like it. And I've had to do a couple of changes because the way they had it without parentheses here and the strings, they didn't have these as strings. They were just using commas and I guess formatting, which was kind of working. But in the output, it really just wasn't coming out well in Grasshopper's output. It was putting things after. Like if I took this and moved it back to what it was, this one, if I just took that back to comma plus string, yeah, if I just took this back to this, which is what they want, you'll see as I test it, it produces search now contains comma. So I just did a little formatting myself. So I'm just going to go back, and those are the little subtle things that I've taken an effort to really fix up. So this will make a smooth transition from Algorithms for Dummies translated into Grasshopper for Rhino Chapter 4, performing calculations using vectors and matrices. And you want to get a copy of the one that is Grasshopper 008 because I even went so far to fix up things that were in the iterative and recursive functions. Hope this comes in handy for all those. Half an hour video. Really excited about GhPython and certainly excited about GhPython Remote. If you want to have details on how to get that up and running, you're probably going to have to talk to me in person or take your time and get it loaded up on your computer. I've had a few friends that have done it really well. Anyhow, hopefully here to help. Michael Wickerson at Wickerson Studios. Thanks for watching.